So my name's Phil Isaac. I guess as Naru may have explained, I come from Australia. I've been here for, well, nearly 3 weeks now. This is actually my 5th time to come to Japan. Yeah, I'm enjoying my time very much here. So thank you to Naruhiko Aizawa and the department and the university for inviting me. It's been great so far. So today I'm going to give a talk on juggling mathematics. So I'm a bit of an enthusiast. It's a bit of a hobby of mine, juggling. So also because my profession as a mathematician, I love to find or to look for patterns in things. So I guess today I'd just like to talk a little bit about how mathematics is a great tool for modelling real life situations. Okay? Now, mathematics is used in many areas of science in particular, and I wonder if you guys some of you can help me out here with my Japanese is not so good. Computer science, maybe computer science. Yeah, is that okay? Also physics, butsuri desu ne. Mathematics is used in physics quite extensively. Chemistry, what? Kagaku? Yeah, chemistry, right, kagaku. And also biology, seibutsugaku, is that right? Yeah, okay. So these are just some examples of areas of science that use mathematics. Okay, now bear in mind, even though today I'm going to be talking about juggling, okay, I'm going to be talking about mathematics applied to juggling, all right, but bear in mind this is really quite serious, okay, it's a serious topic that I want to get the message across that mathematics is very important, okay, so I guess that's the main point of my seminar today, is to try and convince everyone that mathematics is important and a powerful tool used for modelling real life situations, okay, but hopefully with a bit of interesting demonstration as well. So also I have here juggling as maybe it's not so much a science, but certainly it's something that has a lot of patterns. So let me just demonstrate. I brought some of my juggling balls from Australia. So just to start, just to give you an idea, let me start by just juggling. So I can only really juggle 3 balls at a time. At a pinch, I can do 4. But just for today's demonstration, maybe I'll stick with 3 just to be safe. So here I'm just juggling a pattern, just a pattern that's repeated over and over. Okay, I can actually change the pattern somewhat. Okay, so I can manipulate it a little bit, just change it a little bit here and there. So there are various patterns I can do just to try and keep everyone entertained, or maybe not. So a few different patterns. This sort of thing. Okay, you get the idea, right? Oh, thank you. But what I really want to do now is deconstruct that pattern, and I'll actually start with just this simple pattern, this one here, right, with just the balls being thrown from one hand to the other and back again. Okay, so what we might do is deconstruct that pattern, excuse me, or try and represent that pattern in some notation. All right, so let me just start, and I'll see if I can keep time with what's on the screen. Okay, so here we go. Ready? 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, and so on. 11, 12, 13. So as I'm juggling, right, if we keep a beat, so on each beat, 1, 2, 3, 4, right, 1, 2, 3, 4, 5, 6, 7, and so on, I catch and throw the ball. All right, so that's a pretty simple idea. So on each beat, I catch and throw the ball. Now, in principle, what I could do here is just generate a table like this. So I've got the 3 balls here, ball 1, ball 2, ball 3. And the columns are labeling the cycles, okay? So I could generate this table that's just going, getting bigger and bigger and bigger, but perhaps this is not such a good notation, right? This is not such a good way to represent the pattern, all right? So we can ask the question, can we simplify this? All right, so how about we just focus on one of the balls? All right, so maybe I could try changing the color of one of these balls. I'm not sure if you can see this, but these two are red and yellow, yeah? Akai to kiroi, is that right? Yeah, and this one is blue and silver. So what we could do, I guess if I call this blue and silver ball, ball number 1, right? So have a look at where I'm throwing this blue and silver ball, okay? Ball number 1, all right? So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Okay, so you can see here, ball number 1 is actually being thrown on every 3rd beat, okay? And similarly, this pattern is also consistent with ball number 2 and number 3. All right, can everyone see that? Does everyone understand so far? Yeah. So what we can actually do is look at the differences. So here the difference between each throw, the difference between each throw is 3. Okay, so we can see that. So why don't we try representing this pattern simply in terms of the differences? Okay, so this is actually known as the 3 juggling pattern. We can represent this entire pattern, okay, repeated over and over. We can just represent that simply by the number 3, because all the information is contained in this number, because each time I catch and throw a ball, I'm throwing it a distance 3 across each cycle, okay? So we can actually, so these are what we call pattern names. And so each pattern name, so that one I've just shown you is just the pattern represented by the number 3, okay? But each pattern name is actually the shortest, non-repeating sequence of beats. So in other words, we don't write just an infinitely long string of 3s, okay? We don't just write 3, 3, 3, 3. We find the shortest non-repeating sequence, okay, which in this case, it's just 3 repeated over and over. So instead of writing this infinitely long sequence of 3s, we simply represent that as 3. And we understand that to mean that it's just the number 3 over and over. So in some sense, these numbers are representing a throw, okay?